All right, everybody. 8.3, using factoring to verify identities. As we were doing these, you learned what the identities were, the Pythagorean identities, and the basic trig identities, which includes the reciprocal identities. In 8.2, we had the whole table filled out. 8.1, we did it as well. And so it doesn't go away. I gave you a little chart today to help you with that as well. So let's look at making sure that how to apply everything that we know to it. So last time we did fractions, we started figuring out how do we combine fractions with using trig functions. Everything is just like you normally do it in algebra. If I say expand, what we're looking right here, that's telling me that you're going to take, and this means if it's quantity squared like that, that means this is written twice, being multiplied together. Okay, so with that, like that, then it says expand. Well, you know what that is, two binomials, and so we FOIL. So depending on what you like to use, I'm going to do this certainly because I want to make sure that I look at, that you pay attention to what's happening here. Because so 2a times 2a is 4a squared. And then we have plus, I'm going to do these in different colors. 2a times b is 2ab plus b times 2a, which is, I'm just going to write what I said, b times 2a. And then our last one is b squared. Okay, so the next thing that we normally do is we combine like terms. Well, are there like terms? So when you look at these two in the middle, and the reason I wrote them like that, because when we look at our trig identities, they're not going to be just ones that we're used to looking at, but we still have the rules that apply. These are like terms because every variable is the same in each term. So here, I'm talking about two that I highlighted. A is to the first power, and b is to the first power. The number doesn't count. The number doesn't determine whether or not they're like terms, only the variables with their exponents. So I have 2 here, and then I have 2 here. So if I wanted to rewrite this, I could do this so it looks the same, and it's the same thing. So remember, multiplication is commutative. You can switch them and still multiply them and get the same answer. So 5 times 4 is the same as 4 times 5. So just kind of keep that in mind when we start doing our sine and cosine and applying all our trig identities to this. So when I combine like terms, I get 4a squared plus 4ab plus b squared. Okay, make sure that you are paying attention to this one. This is not the same as 4a squared plus b squared. Okay, that is not true. Okay, you're not just squaring everything being taught. You're multiplying two binomials. Okay, let's look at our 3 types of factoring. Actually, I'm going to change this to a 4. And we'll talk about the 4th one after we're done with the first 3. So number 1 is the first thing that we always do, if you remember, is you factor out GCF. And this usually happens, remember, with 2 terms. Okay, so GCF, this is always the first thing we want to do if we can. So it may make it easier for us to eliminate things and so forth, and so it's not such a more difficult looking kind of function we have happening, or equation. So that's the GCF. The second one that I'm going to put here, let's just do 2 terms again. So if I have 2 terms for another one, we're going to think of the difference of squares. We do have the difference of cubes and sum of cubes, but if you notice that we won't be using that as much because of our Pythagorean identities, because those are squares. So the difference of squares. This you will use a lot with those Pythagorean identities because the word squares. There's a difference when you think about when you solve for one of those after you have the first identity, then you solve for one of those terms, you're going to be subtracting, and it's always squares. It has squares and it has 1. 1 is a perfect square. So remember, the difference of squares is a squared minus b squared equals a minus b, a plus b. Now, you should, by now in your math career, mathematics person, of all your time since Algebra 1, should hopefully be recognizing what the difference of squares is. So you need to understand this way to this and this way to this. You may not be able to see that this is actually this, but when you notice something here, you may have to FOIL it, but hopefully you won't have to. And you know, if I take a squared minus b squared, then I have it factored. multiplied out. So knowing that will help you with the what we're doing in verifying identities. Okay, so just kind of keep that in mind. There's a lot of things you want to look at as you go along. Okay. The third one is our trinomial, and that's usually our that's when we do our trial and error. Now the fourth one, sorry, that's kind of messy. The fourth one is actually grouping, and that's usually when we have 4 terms. So trial and error. So try means 3, so that's your 3 terms. And then your fourth one, if you think about, so our fourth one, put it over here, is grouping. And this is when you have 4 terms. So we will do pretty much every single kind. We'll look at this one quite a bit. That'll help us a lot. We want to think about that quite a bit when we do things, especially when a lot of our verifying lends to this type of idea. Okay, so number next. Now, A through D, we're going to factor completely. I'm just going to go through this probably rather quickly, but remind ourselves 2 terms. I'm going to multiply. I'm either going to take the GCF, but these are difference of squares. But let's take out GCF first because I see something in common. Okay, so if I factor out an A squared, and please be careful, you're dividing everything by an A squared, okay, and reducing each term. So anything over itself is 1, okay? You can look at it that way. Or you can look at, okay, I canceled this A squared with this A squared, and it divided it by A squared, so I get a 1 over 1. Okay, it doesn't go to 0, it's 1 over 1. Minus, okay, so this A squared canceled this one, so it's 1 and 1. 1 times B over B, well, excuse me, 1 times B squared over 1 is just B squared. Okay, now, before we go into the next part, because it says factor completely, look and pay attention to what you have. You have to remember, you're not changing the value. You're changing what the equation looks like. So make sure that when you do this, that you're able to distribute back into what you have here. And is it what you started with? If it's not, then you left off something. Okay, so make sure you pay attention to that. But I'm not done because I see that there's a difference in squares. So in here, there's a difference in squares in here, okay? So 1 is a perfect square for everything, and then we have a B squared. So I'm going to use this idea over here, my A minus B, A plus B, because it said factor completely. So I have A squared first times 1 minus B, 1 plus B. And then you're done. Okay? Let's go on to B. B, we have a trinomial. So we'll do trial and error. So one thing nice, this is some simple rules to remind. If I have a minus and a plus, that means I will have a minus and minus. You have no choice. You will also, since this is just x squared, it's just going to be x here, and then what is the factors of 1? 1 times 1. So this kind of turned out really nice. So this is a 1 and this is a 1. But understand that's also the same as x minus 1 quantity squared. You don't always have to change it to this, but you must recognize that this is this, okay? You have to pay attention to what you've done so far and what you've learned. It's there, you've done it. You just have to pull it out and apply it to something different. The one thing about verifying and all these things, if you can think of it as a puzzle and trying to put all those pieces together, it really can help you say, okay, what am I trying to get to? Where do I need to go? And just think through that. And recognizing things as you do, but practicing it is what's really going to help you to do it, okay, to get better at it. All right, so we have here a trinomial again. So I know it's 2 parentheses. Again, a minus and a plus, so it has to be minus, minus. X here and an X here. Okay, so we have a 2, factors of 2, 1 times 2, factors 2 over here, 1 times 2. So wherever it needs to be placed and so forth. That's what we need to do. So if I do a 2 here, then obviously the other one's going to be a 1. Let me write this a little better, I apologize. So I'm going to put it on this side. 2x, and then it's a minus, and then x minus. So all I did was do these factors here. Now, depending on where the next ones go, makes a big difference, because remember, in our rules for factoring, these factors in here cannot have anything in common. So I cannot put the 2 from here in here. Can't do that because 2 and 2 have something in common. So I know 1 goes here and the 2 goes over here. And again, we can check ourselves. Negative 2x, excuse me, negative 4x minus x gives me that negative 5x. So now it's factored. Okay. And then the next one. Okay, so D. Notice that I have a square, 1 minus x squared. And we kind of forget that 1 is a perfect square. It's a perfect square for everything, okay? So just make sure that you pay attention to that. And so I'm just going to take this. I know I have 2 parentheses. According to my difference of squares, it is a minus b, a plus b. So it's 1 minus x, 1 plus x, okay? Please make sure that you're paying attention to that. They do have to be opposite signs, okay? Simple mistakes, and then it kind of frustrates you if you've done all that work and you can't get to that point. Okay, so now let's take all that concept and we're going to apply it to our trig functions, okay, instead of variables. So let me move this thing. Okay, so just like I did above here, I expanded this. I'm going to do the same thing here. We're going to expand this. Expanding means that I have the 2, it's written twice. Wow. I don't know what happened to that one. Sine x plus cosine x times sine x plus cosine x. Okay, expanded. There's 2 of them. Okay, let's FOIL this. So sine times sine is sine squared x plus, and I'm going to do these in different colors. So now I do sine times cosine, and that gives me sine x times cosine x. Oops, don't forget your x. Okay. Next, we have cosine x times sine x. And again, the last term is cosine times cosine is a positive cosine squared x. Please be careful. Notice where I put my square. Sine, I talked about this before, this 2 goes there, or it goes out here. It does not do this, though. That is not the same thing. Here you're squaring the x. Here you're squaring the function, you're squaring the function. So be careful when you do those, okay? So now, like terms. So if you treat all these as just like variables, okay, if you think of sine as maybe x and cosine as y, I have an x and a y, and I have an x and a y to the first power. So I can combine those, and I have 2 of them. So sine squared x plus 2 sine x cosine x. Doesn't matter which comes first, sine or cosine. I have a tendency to write sine before cosine. Don't know why. Probably something I learned back in the day. Okay, so here I have some trig functions, and we're going to factor. Okay, nothing else. I'm not verifying. I'm not trying to find one single term. I'm just factoring. Treat this is a term, and this is a term because they're separated by a minus. So, and these are multiplied. So what's my GCF? So if you think about the GCF, what do they have in common that you can factor out? Well, I can factor out a cosecant x. So cosecant x, okay. Again, I'm factoring it out. So I'm dividing everything by the cosecant x. And then what I need to do is just cancel, reduce the fractions, if you want to say that. So I see that this cosecant is the same as this one over. Remember, top and bottom, exactly the same. Then you can cancel them out. And there you're just reducing those to 1 because you're dividing each by cosecant. So what do we have left? We have tangent x here. Minus, and then now I have a cosecant x divided by cosecant x. Again, 2 ways you can say I'm canceling it, but remember, anything over itself is just the number 1. So this is just 1. Same thing here. I'm reducing this by cosecant x top and bottom, and so when I reduce that by dividing, I get a 1. So either way is fine. Just put the parentheses and you're done. That's all we need to do. Now again, you can check yourself by multiplying this back into here, and do you come up with your original problem that you started? All right, letter B. Now, because you might not be used to sine squared x and all those sitting there and kind of realizing, hey, this is a trinomial. It's a quadratic, just like you would do the other quadratics without the sine functions. So I'm going to show you a substitution way that you can do. You do not have to do it this way, but it might be easier for those who don't see it as well. Or as you do them, it might just be easier. Okay, I see it now that I don't necessarily need this. So since I want this to look like something that I can actually see and factor correctly, what I'm going to do is I'm going to just change the sign part to a variable, and I'm going to let it be a. I would not recommend x because x is in the problem here, okay? So I'm going to let a equal sine x, okay? So if I let a equal sine x, but I have a sine squared, that means a has to be squared. Minus, when I said this is going to be a, so 2a plus 1. Now again, you may not need to do this, but it's just to help me to see that I can see now this is a trinomial I'm used to looking at, and I can do this hopefully rather quickly. So the first thing we'll do, 2 parentheses, okay? And since it's a, I'm going to a here, no anything but a 1 for our factors there, and then it's minus and a plus, so it has to be minus, minus. So this is a plus 1, so this is going to be a 1 and a 1. Okay, now different ways you can do this. I know that I've talked about this before, but you can make this equal quantity squared, a minus 1 quantity squared. So let's do this part where we want to substitute it back in. Now that you've done this, your answer has to be in form of trig functions because that's what you started with. So now replace a with sine x. So here I will have sine x, and this is minus 1, sine x again, because that's a, minus 1. Okay, and then with that, if I had you condense it down a little, I guess today is the word I want to use, that means I have sine x minus 1 quantity squared. Okay, so that equals that. So again, it might be easier for you to see this, for you to use this. Biggest thing is don't forget to put the sines back in and the cosines back in. Okay, so let's factor this one. Again, I'm going to let a equal sine x. Okay, not sine squared, just sine. So I have a 2 in the front. Sine squared x is now a squared minus 5 times a plus 2. And we did factor this earlier in the notes, so I'm going to do this rather quickly. So now that I have that, I know that I have 2a minus 1, a minus 2. So now that I have that, I'm going to replace a. Don't forget to replace your a. So that'll give me 2 times a, which is sine x, minus 1 times your a, which is sine x again. Get the same color. Minus 2. And you're completely factored. That's all you need to do. You can FOIL it. See if you get what you started with up here. It's always how you check yourself. All right, let's do the last one on this page. And we're going to do, hopefully you recognize that this is a difference of squares. 1 minus cosine squared x. 1 is a perfect everything. So what I want you to do with this one is just, you know that I'm not going to let m sine equal anything or cosine. You can if you want to. But you know that no matter what you have here is you know that you have 2 parentheses. It's a difference of squares. The 1 square root of cosine squared is just cosine x, and then I have 1 has to be minus and 1 has to be plus. And if you needed to replace 1 and see that's 1 minus a squared or something like that, then you can. I'm just not going to do it for this time, okay? Let's go on to the next page. Okay, so we're going to apply what we learned today with verifying the following with verifying our trig identities. So remember when we're doing these, you have to pick to one side. We learned this 8.2. And pick one side only to work with, and you cannot touch the other side. Your objective is to make whatever side you pick to look like the other when we get done using your trig. Identities, algebra, everything to get there, as long as it's, legal moves. So the first thing we're going to look at is what side do you pick, okay? I feel like I have more that I can work with this side right here. So I'm going to use that side first, okay? I'm again not going to touch anything. Like I said last time, I prefer to work straight down and don't, I probably don't really prefer to put equals and then put that 1 minus 1 over secant squared x, but I'll show you what I mean when I do that. So, okay, so when I think about it, and this is where you have to kind of look at your identities and so forth. If you notice, I just have no pluses or minuses. So when I have plus or minus over here, I have to somehow get rid of that. I have a secant squared, and so it's 1 over secant squared. So it's a reciprocal of something. And if you look at your identities, 1 over secant squared is reciprocal of 1 over cosine squared. So what I want to figure out, how do I get a cosine and then have the reciprocal of that? So when I think about it, this is, hopefully you notice that this is a difference of squares. It's just factored. So what I do is I know that if I'm going to write it, this has to be a squared minus b squared. So a is 1 and b is sine, and I'm going to square it. If you didn't know what for sure to do, then FOIL. Okay, just FOIL, and you shouldn't have a middle term. Okay, so let me write that a little better. So then this would be 1 minus sine squared x. Again, difference of squares, a squared minus b squared equals a minus b, a plus b, doesn't matter which one comes first. And that's what I see. So that's why I'm able to write what I have underneath here. Okay, and then I'm just going to say equals. Okay, so now, like I talked about, I said I know that secant squared is the reciprocal of cosine squared. So if I look at my identities, I can actually change that to cosine squared x. So if you remember from your identities, you have sine squared theta plus cosine squared theta equals 1. This right here is what you'll use a lot. It always helps you to get the other identities by just using this. But remember, you can solve for each one of these. So if I have a 1 minus sine squared x, that means I had to solve for cosine squared x. Because if I subtract sine squared from both sides, and we did this in our notes, I changed this a little bit. So if I subtract both sides by sine squared theta, I'm left with cosine squared theta on the left equals 1 minus sine squared theta. And that's what I have here. I just don't have theta, I have x. It doesn't matter. Any variable can be in here, okay? It's just a variable. So, so now that I see that, okay, so now I know that this equals this. And we said earlier, if I can get this side to be a cosine squared theta, then I know it's the reciprocal of secant squared theta. So I'm going to let this equal to cosine squared theta. Okay, equals. Again, I'm not bringing anything down. But to finish this off, you have to show me how you know that cosine squared theta equals 1 over secant squared theta. So that means you're going to change that to the reciprocal. Again, we have to show that work. There's never an assumption that somebody knows it, okay? And remember, all this work is the answer, not this final step. Okay, so I know cosine squared theta. If I look at my basic trig function identities, then this is the reciprocal of 1 over secant squared theta. And that's what I have over here. Oops, I said, sorry, I'm changing it, aren't I? So this should be, that should be x. So I just showed and proved or verified that I can change this right here to this. Again, all of this is the answer. Okay, so now we know that both of those are true. It makes a true statement. Make sure that it's not false that you know you don't have something that doesn't make sense there. It always has to be true, and they have to be exactly the same. So now you're done. Okay, let's erase this stuff over number 2, and let's do number 2. Okay, with number 2, I have 2 terms here, and it has, whatever I do here has to equal 1. I'm going to pick the the left-hand side to work with, because that's what I have more to do. The more that you can actually move things around, change it, it'll probably be easier on you to make sure that you get to verify to the left or the right, whichever one you're working with. Okay, so I have 2 terms here. I see that they all contain a cosecant squared x. Now, 2 terms we run a factor, but why would we want to do that? First of all, we have a minus here. We have to come up with just the number 1. Whatever we do mathematics-wise, the way it works, the only way I can get 1 is if I cancel everything on top and bottom, and I just get left with the 1, and that will help us know that. So how do I do that? Well, I got to get rid of that minus because that's not going to help in a sense. So we may have to be multiplying stuff together that can help us to reduce that. So let's just start with factoring our GCF out. So we're going to factor a cosecant squared x. So I'm going to divide everything by cosecant squared x except the other side. Okay. So when I factor that out, I am left, this cancels to a 1, or anything over itself is 1. These each cancel and divide by cosecant makes a 1. So this is a 1. And over here, I can see that this is the same as this on top and bottom, so I can cancel. And those go to 1, and I'm left with a minus cosine squared x. And that has to equal the 1 over there. Now, I'm down to where, okay, I have something like that. But if I notice I have a cosecant squared here, and if I had the reciprocal, which is sine squared, then I can actually cancel them out and make it 1. So what you do is once you see something like that, check your identities. What can you use? Well, I know that 1 minus cosine squared x is sine squared x. You have to have these memorized for your quizzes and tests. There's matching on their stuff, so you're going to have to make sure that you know those, okay? All right, so what we want to do is, how do we make it 1? Well, if we think about it, whichever way you want to go, if you change this to a reciprocal of sine squared x, then you'll get 1 over sine squared x. And you're multiplying it to this sine squared x. That's in the numerator, so if you need to, put that over 1. And then anything the same top and bottom, mathematically, I get to cancel it. So when we look at that, is that going to get me to my 1? Well, yeah, because this divided by sine squared x is 1. This divided by sine squared x equals 1. So I am with 1 times 1, top and bottom, 1 equals the 1 on the other side. So you verified it. Again, the whole thing is your answer, not just that last statement. All right, number 3. I think I'm going to solve using the left side. A lot of times it seems to be the left side, but not always. So because I feel like there's more work. And then pay attention to what you have here. You have a fraction on this side, but there's no fraction on the other side. You have a minus here, but this needs to be a plus. And there's no squares. Squares are all gone. So when you see that square and you're seeing that things are like possibly no longer have that square, where do I get that information? What do I use? Also to think about too is that hopefully after a while you'll see it. And I know that if these were multiplied together, they would give me a difference of squares. And maybe if I have a difference of squares, then I can change it to what I want. Okay. So let's see what we can do. So the first thing we want to do is change something so that it's the same. So if I see this here, how am I going to get rid of that 1 minus sine x? Let's see. So I'm going to change this identity to 1 minus sine squared x. I don't want any cosine squared x. It's not helping me to get to the sine x on the other side. It's not a square, so sine squared over here, there's no sine squared, so it's not going to help us to get to that side. So let's get rid of it. So 1 minus sine squared x equals cosine squared x. And then on the bottom, I have a 1 minus sine x. All right, so now I've gotten rid of cosine. Again, I'm not going to touch anything on the right. I'm only dealing with the left. So let's think of how we can somehow get rid of this 1 minus sine x on the bottom, but happen to maybe wind up with the 1 plus. So I change this. I need to get rid of this square. The only way to get rid of the square is to factor. Okay, this is the difference of squares. So a is 1 and b is sine x. So on the top, I have 1 minus sine x times 1 plus sine x. That's just the numerator. And my denominator did not change, so it's all over 1 minus sine x. Great. I see the 1 plus sine x, but now I got to get rid of the stuff I don't need. Just remember this is binomial. You can put these in parentheses so that you remember they stay together. Cannot just cancel sine x's. You have to cancel the whole thing. So now I see that there's a 1 minus sine x on top, a 1 minus sine x on the bottom. So this cancels with this, goes to 1. And what do I have left over? I have 1 plus sine x equals the 1 plus sine x from above. And we verified. Now again, all of this is the work. Please make sure you're showing your work. Okay. With number 4, I see 3 terms at the top. Sine squared theta minus 2 sine theta plus 1 divided by 1 sine theta minus 1. Now, my objective is to get, I'm going with the left to work with the right again, and my objective is to just get that sine theta minus 1. I notice it's in the bottom of this fraction on the left side. So if this is it right here, and that's over there, so something has to possibly cancel to leave me with this. The only way I can get this. Notice there's no squares, and it's only 2 terms where I have all this divided by this, okay? So when we see that, we have a quadratic happening, even though it's a sine. There's still a square there. We're going to factor. Now, on this one, this is where I'm going to let a equal to sine theta. I'm always going to pick a because unless they have it, sine theta. So when I rewrite this, I can rewrite it as a squared minus 2 times a plus 1 all over a minus 1. Now I can look at that and not worry about all those signs and make it look messy. So we just factor. Okay, so we can factor this. We know that we'll have an a and an a. It's a minus and a plus, so it has to be minus, minus, and the factors of 1 are just 1 and 1. And then on the bottom, I have a minus 1. So let's just stick with our rules. What can we do? We have something the same as the top and bottom, so I can simplify. So I can cancel this one and this one. Okay, I still have one left over. So now let's put that there, and we have a minus 1. Now the only thing is we got to remember to replace a. So I'm going to replace a with sine theta, what I had at the beginning, but I still have that minus 1, so I'm just going to leave it there, okay? Now that has to equal the other side. So it's exactly the same. So now I have verified. Again, I'm just going to put my equals here to kind of show you where I'm going with my work. Okay, number 5. Okay, so number 5, I see that there's more work on the left-hand side, so I'll do that. So when you look at things, kind of pay attention to this. This right here, when you see it, pay attention to what you have there so you can say, oh, wait, that might be something. So this right here looks like it could be an identity we have, right? It's something that we have, but not quite. So that looks like an identity, so I'm going to think about that. So this looks like an identity. So identity I'm thinking of is I know that one of the variations, I have sine squared theta equals 1 minus cosine squared theta. It's not quite what I have, but it's close. So but it also helps me, but when I look at the right side, I need a negative. There's no negative up here. I have to have a negative. I need this to be cosecant x, so we want to think of reciprocals. Reciprocal of cosecant x is 1 over sine x. So anything like that will help us to kind of figure that out. We want to do that, okay? We have no fraction on the right, so we have to somehow get rid of a fraction, which probably means we're going to have to cancel something. So let's take a look at this really quick. How do I get this to look like this so I can use that? Because if I say this is sine squared theta, then I have a sine x over a sine squared x, okay? So let's see. I know that if I take out a negative, so I multiply this, so I'm going to kind of move this out of the way. We're going to bring, so I kind of just moved it over here to the side so I can see what I'm dealing with. So again, I need this to look like this. Well, 1 is positive, I have 1 negative. Here, cosine is negative, but it's positive. So the only way you can do that is to factor out a -1. So in the numerator, we'll stay the same. Sine x over, if I take out a negative, I will have negative cosine squared x plus 1. I'm going to rewrite it because I feel like it's more pleasing to my eye because I'm used to it looking like this. Okay, so now that I have that, maybe that'll help me to deal with something. Well, look what happened. I have a negative now. I created that negative. All right, so now I have that. So now I just get rid of the fraction. So what do I need to do here? I need only sine x because we talked about the reciprocal identity for cosecant x is 1 over sine x. All right, so let's see if we can get that. So I know based on this that I just found out here that 1 minus cosine squared x is sine squared x. So I'm going to have on top, keep the fraction the same, trying to not use up all my room. And then on the bottom, this becomes negative sine squared x. Just redoing my identities, using those to help me. So as I keep going, again, I like to put these here just so I don't always like to bring down what's on the right on the other side because I have a feeling sometimes I'll mess up and use it. Okay, so now I have 1 here, I have 2 here. It's the same if I had an a on top and an a squared on a negative a squared on the bottom. I can reduce, okay? I can reduce a sine x with the other one. So I'm going to reduce this one will go to 1, and then this will just go to a negative sine x. So now if I rewrite that, I have 1 over negative sine x. That has to equal negative cosecant x, and it does, because the reciprocal of 1 over sine x is cosecant x. Don't forget the negative, and it has to equal the other side exactly the same. You have to do all these steps. You cannot just say 1 over negative sine x equals negative cosecant x. You must go to this step, and these must be identical when you're done. Everything's the answer. Okay, last problem. Now, you notice there's 4 terms. So when we have 4 terms, we're going to factor by grouping. Now, I'm obviously, and I hope it's obvious too, I shouldn't say that word, but there is a lot more work I can do on the left than I can do on the right. Okay, so let's think about what we need. We need to somehow get this thing over here to be just a cosine x minus 1 without, without a fraction. There's no negatives in there. And so we're going to have to factor first. So every time we see something like this, we're going to factor. So let's factor this. I'm going to first set a to equal to cosine. So I'm going to let a equal cosine x. And if you think about that, that's just saying I have a cubed minus a squared minus a plus 1 over, let's do a squared minus 1. So now let's just factor. So on the numerator, we have to factor by grouping. I'm going to group these two. I always, if there's a negative, group that negative with the variable that's right there. And this is really just a plus. I just put it inside there. It's just easier for me to make sure that I actually take a look at that second binomial and do what I'm supposed to do. So the first thing we do for between a and a squared, what do they have in common? A squared. So it's going to be a squared factored out, and we are left with just a minus 1. Again, distribute, see if you get the same thing. Now this is my hint. It's always our hint, and so we want the other side to be a minus 1. So how do we do that? Well, if it's a negative a and a positive 1, I'm just going to pull out a negative 1. So we're going to pull out a negative 1. And I am left with a minus 1. Now, these two are the same right here. So now let's factor that out. And we have a, man, I can't even forget to do that. We have a minus 1 for what I have in common. So it means I'm dividing this by a minus 1, dividing this by a minus 1. And those a minus 1 cancel. So what's left over here? We have a squared. And here we have the minus 1. That's the numerator. And I'm going to bring the denominator over here. All over a squared minus 1. I hope that coloring is not confusing to you. Okay, so now, if I look what I need on the other side, I don't need squares. Squares need to go away, okay? So if I look at what's on the other side, I just have a cosine x minus 1. So I need that kind of left over here. So when I look at it, well, what can I cancel out? Well, those a squared minus 1s cancel out. Remember, this is a binomial. So I can take that, divide by a squared minus 1 and get a 1. Take that, divide by a squared minus 1 and get a 1. So what do I have left on top? A minus 1 times 1 is just a minus 1 over 1. But I'm not quite done, because now I need to replace a. So remember, you can start with the trig function, you must end with the trig function. So a is now, a we said up here, again, it was cosine x. So this is cosine x minus 1. And is that what we had on the other side? Yes, we did. Cosine x minus 1. Some areas that went away. So look at just carefully what you're doing as you go along. If it helps, sometimes I number my steps so I know that I'm still together with my steps. I will do just different things to make sure that I'm not losing what I'm supposed to be doing. Again, the best way to get better at this is to keep doing the problems. Always look at what you're looking for when you're verifying the following. What am I trying to get to? How can I get there by what I know?